Hello everyone and welcome to lecture number 4. So let's start our class. We already know what is algorithm. Let's review the algorithm. An algorithm is a finite sequence of precise instruction for performing a computation or for solving a problem. It must produce the correct result. It must finish in some finite time. You can represent an algorithm using pseudocode, flowchart, even actual code. You can see here there is a input, then our algorithm, then this is the output. Basically, what is algorithm? Algorithm is a process to solve a problem. For example, this is your let's say this is your home and this is your school, and you have to go to a school by this road. You decide that you take a bus and go to your school. So this is the algorithm. You took a bus then go to school. This is a one algorithm. Also you can uh, go to school by walking, or you can take cycle, whatever you take. Everything is an algorithm. If you talk about a precise code, then you can talk about this. For sorting, let's say 6 5 1 2 3. For sorting, you check one by one, then sort it, or you can do insertion sort. You can take it as a key 5, then check with this one, then it will be 5 6 1 2 3, then key will be this one, so one will come here. So this is the one of the algorithm to sorting this array. So this is algorithm, very basic and important thing. Now we discuss in this lecture complexity of algorithm. How much resource is needed by an algorithm, typically measured by time complexity and space complexity. Basically we talk about the time complexity because space mean memory, and memory are very cheaper day by day, so this is considerable. So we just talk about in this lecture time complexity, and the next lecture we deep dive into time complexity. So don't mix up problem complexity with algorithm complexity. This is very important. Some of you mix up with these two. So algorithm complexity deal with the complexity of a specific algorithm, and problem complexity indicates how hard the problem is. Example, NCP problem are so hard to solve that no matter how clever algorithm you design, it will not be solve such a problem easily efficiently. We already talk about NP class, NPC class. So if you don't know about this, you can watch the lecture 3 or lecture 2. So informal notation of running time mean runtime. Express runtime as a function of input size n. You can also call function of n is order to understand how fn grows with n and count only the most significant term of fn and ignore everything else because those will not affect runtime must for very large value of n. Those the running time, also called time complexity, of the program of the previous slide becomes. So let's say fn is a function and c into n1 is less than equal n into some constant. So this is our function. From this function we write the big one. big one here, because in time complexity you always take the worst case. It helps to analyze the algorithm best. So this is the worst case. We take n into some constant. Those both these functions are bounded from above by some constant multiple of n, and as such both have the same upper bound. Order of n. We can write it order of n. This is the time complexity or notation we use for express time complexity. This means that the running time of each of this algorithm is always less than or equal to constant multiple of n. We ignore the value of constant in the big O notation. We never write order of 543n. It is actually order of n because this constant term we ignore whenever we write time complexity. In this function, this is order of n, this is order of 65 n square plus 34 n plus 7. So we take the worst case and constant don't need to consider. So the time complexity of this function is order of n square. We compare run running time or runtime of different algorithm is an asymptotic manner. For example, we check if function of n is greater than function of g for very large value of n. That's why the task of computing time complexity of an algorithm is also asymptotic analysis. If you think about why we learn the time complexity, so this is very crucial whenever you learn algorithm or write a code, because most code which are accepted, they are their time complexity is lesser and efficiency of the code is higher. So you can see in the table, this is our number of input, this is our number of input, then this is the time complexity, this is order of 1. Order of 1 means constant time, this is did not depend on number of input. Log n, this is log n, order of log n. So this all the time complexity and their output or time increased by input size. You can see here for 2 to the power n, if we take 1000 input, then this is the time complexity. This is a huge number. So if we use this algorithm, this will take only 9.97 seconds. So you can compare between this, that algorithm complexity is very important, and if we write a efficient code, then our algorithm run faster and it's acceptable for all the field. So we learn more about time complexity in our next lecture. So that's all for today. Thank you everyone.